This lesson is on simplifying rational expressions. In this example, the numerator is a monomial and so is the denominator. So our rules are pretty simple. We simplify 4 and 10 like they're normal fractions. They're both divisible by 2. 4 divided by 2 is 2, and 10 divided by 2 is 5. And then we look at our variables. We have x to the first on top and x to the second on bottom. The question we were asking in class is, where do we have more x's? Well, we have x on top and x times x on the bottom. So we have more x's on the bottom. We have one more x on the bottom. So this cancels to become just x on the bottom. So we have 2 over 5x. When we get into having binomials and trinomials, then we have to do a little more work. We need to factor each piece. So on the top, we're going to look first and see if there's a common factor, and 3x and 3 have a common factor of 3. So we're going to factor that out, and we're left with 3 times x minus 1. On the bottom, we don't have a common factor, but x squared minus 1 is a difference of perfect squares. Remember that special factor pattern, a squared minus b squared, always factors to the square root of a squared, which is a, plus the square root of the b squared, which is b, times a minus b. So since we have x squared minus 1, the square root of x squared is x, and the square root of 1 is 1. So we're going to have x plus 1 and x minus 1. Once we're here, we look for what factors do the numerator and denominator have in common. On the top, we have a factor of 3 and a factor of x minus 1. On the bottom, we have a factor of x minus 1 and a factor of x plus 1. The factors they have in common are an x minus 1. That's the only thing they have in common. We're left with a 3 on the top and an x plus 1 on the bottom. So our final answer is 3 over x plus 1. We're going to do the same thing here. We have binomials, so we're going to start by trying to factor them. X and 2 don't have any common factors, and they're not a difference of perfect squares. So what I would just do is put parentheses around them so that you know that if they're canceled, they have to be canceled as a group. You can't just cancel just the x. On the bottom, you have 4x minus 8. There's a common factor there of 4, so we're going to factor out the 4. And we're left with x minus 2. Now if we look at our numerator and denominator, they have a common factor of x minus 2. So we're going to cancel those common factors. We're left with a 1 on top and a 4 on bottom. So this simplifies to 1/4. Okay, this one we have a binomial on top and a trinomial on the bottom. X plus 3, does it factor? Well, we want to ask, does it have any common factors? And it doesn't. Is it a difference of perfect squares? No, it's not even a difference. So we're going to put parentheses around it because it doesn't factor. And remember, if we cancel, we have to cancel the whole thing. Then we're going to factor x squared plus 6x plus 9. We look for a common factor first. There's no common factor. So we're going to go ahead and draw our parentheses. To get x squared, we do x times x. And then we need factors of 9 that add to give us 6. So that's going to be 3 plus 3 and plus 3. That's what we've been practicing. We see they have a common factor of x plus 3. So that cancels. We're left with a 1 on top and an x plus 3 on the denominator. So 1 over x plus 3. All right, we'll look at this one. We have a monomial on top, and monomials don't factor. We have a binomial on the bottom, but x plus 1 doesn't factor, so we're going to put parentheses around it because it needs to cancel as a whole. At this point, we look to see if there's something we can cancel, and they have nothing in common. The only factor that x has is x and 1, and the only factors on the bottom are x plus 1 and 1. So since they have nothing in common, this doesn't simplify. And I want to give you a couple of examples to think about with that one. Think about, what if x was 5? If x was 5, we'd have 5 for the numerator and 5 plus 1 on the denominator, so 5/6. Does that fraction simplify? No. Well, what if x was 10? We'd have 10 over 11. Does that simplify? No. What if it was 8? That would be 8 over 9. Any of those fractions that we think of where the denominator is 1 more than the numerator, they don't simplify. So we leave that just the way it is. Here we have 4x minus 12. It's a binomial, so we're going to look for common factors. And there's a common factor of 4. So we'll take out the 4. We're left with x minus 3. The bottom's a monomial, 8x. So here we have the 4 and the 8 are both part of monomials. So those can simplify. 4 goes into both of them. We have a 1 and a 2. So we're left with x minus 3 over 2x. The x's can't simplify because the top x is part of that binomial, and it has to cancel as a whole group. All right, one more. X squared minus 3x minus 10. We start by factoring it. Is there a common factor? No. So we're going to go ahead and draw our parentheses. To get x squared, we do x times x. We need factors of negative 10 that add to give us negative 3. So it's going to be negative 5 and positive 2. On the bottom, we have a binomial. There's no common factor, but it is a difference of perfect squares. So that factors to x plus 5 times x minus 5. We look for common factors on the top and the bottom, and we see they both have a factor of x minus 5. And we're left with x plus 2 on the top and x plus 5 on the bottom. Can our x's cancel here? Well, the answer is no, because x is part of a binomial x plus 2, and the x on the bottom is part of a binomial x plus 5. And the only way they can cancel if there's addition or subtraction is if the whole thing cancels, like here where the x minus 5, the whole thing cancels. So this stays just like this, x plus 2 over x plus 5. So here are your steps. You always start by factoring the numerator and denominator. Look for those common factors. We see a lot of those. Look for that difference of perfect squares, like x squared minus 9. Factor any trinomials, and then cancel out common factors. And that's it.